In this lesson, we'll be talking about substitution, or U substitution, which is generally the first integration technique you are taught in calculus. The idea behind U substitution is to take an integral that you don't know how to solve, namely number 1 here, and transform it into an integral that you do know how to solve by changing the variable. The technique of U substitution is sort of a reverse of the chain rule. So if we recall the chain rule here, we have the derivative of a composition of two functions, f of g of x, is equal to f prime of g of x times g prime of x. So if we write this in terms of integrals, we have the following. The integral of the left side and the integral of the right side becomes the integral of f prime of g of x times g prime of x dx is equal to now the integral of the left side. Well, we have the integral of the derivative, and they cancel one another off, and we just have f of g of x plus c. And the technique of U substitution is to change the variables here. So what we are going to do is introduce a new variable u, which is going to be this g of x function. That means if we take the derivative, du dx, then we have g prime of x. And if we multiply both sides by this differential, we have du is equal to g prime of x dx. So if we make our substitution now, this integral here becomes f prime of g of x, well that's f prime of u, times g prime of x dx, which is exactly our new du. And this is equal to f of g of x, which is f of u plus c. So the idea is to make the integral simpler by making a substitution by choosing u as this g of x. So the question becomes, how do we choose this function? The way that we will choose the function u is always going to be this g of x function. And notice that g of x is a function that is inside of another function. So what we want to do is we want to choose u to be an inside function, meaning it is inside of some other function. When we return to our original problem, we see here that this function x squared is inside of the sine function, which means that we're going to choose u in this case to be x squared. If we calculate du dx, we get 2x, which means then that du is equal to 2x dx. And now we are ready to make our substitution. Well, we have the integral of sine of x squared is just the integral of sine of u. And what we have left here is 2x dx, which is exactly our du. And now we have transformed this integral into an integral involving u. Well, we know the antiderivative of the sine of u with respect to u is negative cosine of u plus c. Our original problem involved the variable x, so we should go back to the variable x, and in this case, negative cosine u is negative cosine of x squared plus c. And we find then that the integral of 2x sine of x squared dx is equal to the negative cosine of x squared plus c, and we have our answer. And always, you should be checking your answer here, and to check it, we want to take the derivative of negative cosine of x squared plus c, and it's no coincidence that in this case, in order to check your derivative, to check your antiderivative, we will be using the chain rule in this case. Well, we take the derivative of negative cosine, which is positive sine, we leave the inside function of x squared, multiply that by the derivative of the inside function, which is 2x, the derivative of plus c is 0, so we are back to our original integrand, and we know we have the correct answer. So the important thing to remember here is that when we are choosing our u substitution, you always want to choose u to be an inside function, inside of some other function. Now, the technique of u substitution is not always going to work, but it is one of the first integration techniques you should try on an integral that you do not know how to solve.